Hello dear students, I welcome all the standard 10 students on this online classes. So previous class already we have discussed about the question answer which are given in the section exercise. Okay, already 10 number of question already we have discussed and I hope all of you have understood that one properly. Today again 10 more question we will be going to discuss. Okay, so without delaying, let's get started this one. Okay. So the 11 number question, give one example of each. A body possessing rotational energy. You know that one rotational motion means what? If any object is moving along a circular path or around a fixed axis, then that one is called as rotational motions only. So any object when it rotates about an axis is having rotational kinetic energy only. Yes. So that one is the example. Then vibrational kinetic energy or vibrational energy, vibrations of a tuning fork is the best example. In that case, that object or the vibrating tuning fork possessing vibrational energy. Here directly it is mentioned vibrational energy, rotational energy. But while an object is rotating at that time, obviously it is in the state of motions, and while it is vibrating at that time also it is in the state of motions only. And you know that one, if any object is in the state of motions, then it must have that kinetic energy. So first one is the rotational kinetic energy also we can say, then second one is the vibrational kinetic energy also we can say. Okay, simple one only. Number 12. State energy changes which takes place in these microphone, electric bulbs and a steam engine. This one is also very simple one. It is given also in your book. Microphone from sound energy to electrical energy. Then electric bulb, electrical energy to heat and light energy. When that filament of the bulb start heating at that time, after some times only, that means it is happened within just very few seconds. Yes, not few seconds, less than very few seconds also. Okay. So when that filament get heated, it start glowing and gives rise to light energy. Okay. So electric bulb, electrical energy to heat and light energy, then a steam engine, heat energy to mechanical energy. Because of the steam also that blade of the turbine can rotate. So mechanical energy we can get from the steam, that is from heat energy to mechanical energy. Okay. Then number 13, a girl sits and stands repeatedly for 5 minutes. Draw a graph to show the variations of potential energy of her body with time. See here, a girl is there who is sitting and standing repeatedly for 5 minutes. Okay. Then we have to plot a graph to show the variations of potential energy of her body with time. So we have to plot the graph, we have to take the time on the x-axis and potential energy on the y-axis. Yes, on the x-axis, time axis, that one. So we have to divide that one up to 5 minutes, that is 1, 2, 3, 4, 5. Okay, and the y-axis is having the potential energy. And you all know that one, while that girl is standing at that time, what will happen? That potential energy increases, and while she sitting at that time, that potential energy get decreases. Again she is standing, again the potential energy increase, while she is sitting at that time, again its potential energy decreasing. So increasing and decreasing it is happening. So I will show you that one. Let us see. See here, this one x-axis, this one is y-axis. Okay, here 1, 2, 3, 4, 5 you can take. Yes, it will be like this only. Yes, the potential energy increases, potential energy decreases, potential energy increases, potential energy decreases. Okay, so this one is the graph. Simple one also this one. Then number 14, state the transformations of energy taking place while using the following. First one is the loudspeaker. In case of loudspeaker, electrical energy get converted into sound energy only. Then washing machine, electrical energy to mechanical energy only. Okay. So this one is also simple one. Then next, the problematic part, 15 number. Okay. A body of mass 60 kilogram has the momentum 3000 kilogram meter per second. Calculate the kinetic energy of the body. So how to calculate that one? Previously several times I said that also, while we are solving any word problems, first we have to write all the given things. So mass is given, m is equal to 60 kilogram. Then one more thing is also given, momentum is equal to 3000 kilogram meter per second. That is mb is equal to 3000 kilogram meter per second. Mass is given. So from that equation, that is mb is equal to 3000 kilogram meter per second, we can calculate velocity also, and it will come v is equal to 50 meter per second. Okay. So after calculating the velocity v is equal to 50 meter per second, from that equations mb is equal to 3000 kilogram meter per second, we can easily put all the values in that kinetic energy equations, that is half mb square. So half into mass is how much? 60 into velocity is how much? 50. So after calculating that one, what we will get? 75,000 joule. You must try this one. Okay. In that way you can solve that number. Then the next one, number 16. A body P has kinetic energy E. Another body Q whose mass is 9 times the body P has kinetic energy E. So what are the given things here? P and Q, two different bodies are there. Both are having same kinetic energy, that is E. But both are having different mass. One is having mass m. If we will take the mass as m, then another one is having mass 9m only. Okay. Let us consider. So here the question is asking, calculate the ratio of velocities of P and Q. So let us take the velocities of the body P as v1 and the velocity of body Q as v2. Okay. And you know that one, kinetic energy is equal to half m v1 square for the first body, that is P, and the kinetic energy for Q, that is half into 9m into v2 square. Yes or no? Because it is mentioned here that another body Q whose mass is 9 times the body P. Okay. So if the body P is having mass m, then obviously according to the question that a body Q is having mass 9m only. So the kinetic energy is equal to half into 9m into v2 square. Okay. So from both the equations we will get v1 and v2 also. Then we have to find out the ratios between them, that is v1 is to v2. It will come 3:1. So before that v1 will come 2e divided by m, or root over of 2e divided by m. Then v2 will come 1/3 into root over of 2e divided by m. Okay. So while taking the ratios at that time, from both the equations, one common term will come, that one will be cancelled, and it will come 3:1. Okay. Then the next one, number 17, a 3.30 into 10 to the 6 kilogram Saturn rocket takes off from its launching pad and acquires a vertical velocity of 1000 meter per second at an altitude of 25 kilometer. Taking g is equal to 9.8 meter per second square, calculate its potential energy and kinetic energy. So this one is also simple one, all the given things are present. So first you have to check it out that whether all the physical quantities are given in the SI system or in other system also. If it is not given in SI system, then it is better to convert that one to SI system. Okay. So here the altitude is given 25 kilometer, and you know that one meter is the SI unit of height or altitude. So we have to convert that one. 25 kilometer is equal to 25,000 meter. Yes or no? Yes. So we have to convert that one first. Then mass is given 3.30 into 10 to the power 6 kilogram. Then velocity v is equal to 1000 meter per second. Then g is also given 9.8 meter per second square. Then simply just we have to apply all the values in that equations of potential energy and kinetic energy, that is mgh and half mp square. Directly we have to put the values, and after solving that one we will get the answer. Okay. So in some cases in the answer it is given like that 8.085 into 10 to the power 11 joule, but your answer will come, maybe it will come 8085 into 10 to the power something. So we can change the decimal point also. So by changing the decimal point we will get the answer also. You must try this one. Okay. Number 18. A car weighing 1000 kilogram traveling along a level road is accelerated for 2 minutes at the rate of 15 meter per second. Find its gain of kinetic energy during those 2 minutes. You all know that one. Here the question is asking find the gain in kinetic energy, and gain in kinetic energy, how can we calculate that one? Final kinetic energy minus initial kinetic energy only. Yes, in that way we can calculate. So here what are the given things? Mass is given 1000 kilogram. Acceleration is given. See here, at the rate of 15 meter per second it is given, but at the rate of accelerated for 2 minutes at the rate of 15 meter per second. So this one is the acceleration, that is a is equal to 15 meter per second square also we can write. Okay. Then time t is equal to 2 minutes. So we have to convert that one to second, that is 120 second. Then initial velocity we can take here as u is equal to 0. Then what we have to calculate? V we have to calculate. Yes, v is equal to u plus at. That formula, that equations of motions we can use, and we will get 1800 meter per second fast. Okay. So v is equal to 1800 meter per second. It will come. Okay. And how can we calculate that one? By using the equations of motions, v is equal to u plus at. Then gain in kinetic energy half mv square minus half mu square. Just simply then we have to put all the values, because we have already calculated the value of v, and u is also there, that is 0. That half mv square minus half mu square, it will come 1.62 into 10 to the power 9 joule. Okay. You must try this one. Okay. Then number 19. A car has a velocity of 90 km per hour. When it begins to ascend a hill without any help from its engine, to what height will it rise before coming to rest if 1/3 of its energy is lost in frictions? So first try to understand the question, what the question is asking and what it is given. Okay. So you all know that one, while we are moving upward directions, what will happen? Our potential energy get increases, and there is also that transformations of energy occur. So from the kinetic energy to potential energy it is transforming. Okay. So in this case, that potential energy is equal to kinetic energy minus 1/3 of kinetic energy is lost because of the frictions. Okay, we can equal that one, because kinetic energy get converted into or transformed into potential energy while it is moving upward directions. Yes. So that's why only potential energy is equal to kinetic energy minus 1/3 of kinetic energy is lost due to friction. Okay. So kinetic energy minus 1/3 of kinetic energy, it will come 2/3 of kinetic energy. Okay. And you know that one, potential energy is equal to mgh. Yes. So mgh is equal to 2/3 into 1/2 into mv square it will come. Then we have to put all the values, simple one only. Just simply we have to put the values of v and g, and after solving that one we will get 21.2585 it is coming, but in your book it is given 20.833 meter. Okay. Then number 20. A small plane with a mass of 1200 kg cruises at 140 km per hour at an altitude of 1.5 km, taking g is equal to 10 meter per second square. Calculate its potential energy. This one is also simple one. mgs is the formula. Just simply you have to put all the values, and before that you have to convert that one. What you have to convert? That v you have to convert. That is 140 km per hour it is given, you have to convert that one to meter per second. So while converting that one, it will come 38.99999. Okay. So we can round up that one, and also we can write as 39 meter per second also. Okay. Then 1.5 kilometer it is given, then that one also we have to convert that one to meter, that is 1500 meter only. Okay. Rest of all the things are given in the SI system. So simply you have to put all the values in that equations of potential energy and equations of the kinetic energy. You will get the answer. Okay. You must try to solve this one. Easy one. Okay. Thank you.